So my name is Oliver. Hey everyone. I work for a company called Holiday Extras. I am in the Tech Foundations team, and the remit of our team is to improve the productivity of the rest of the team. So I'm the software engineer in the team, and I'm accompanied by two infrastructure guys who've been building all kinds of wonderful things with Kubernetes and all the things, the metrics and logging and everything that you kind of wrap around that. So I'm going to talk through kind of how we go about building microservices, what this looks like from an engineer's perspective, and all the kind of tooling and stuff that we've built around this to make this process really easy, and like how we've got containers into production. Before I crack on, I'm got to get a train home today, and it's pretty chaotic out there, so I'm going to have to vacate pretty quickly after this talk. So I apologize, because the best part about coming here is talking to all of you. So is like the best next thing I can do is put my Discord thing at the top there. So if anyone like has some burning discussions that they want to have about something on here and you don't want to, there's not time at the end, you're welcome to hit me up. So apologies on that one. Okay, so on the left here we've got engineers. They create repos. They then write code, builds run, produce containers. Containers go to production. And I'm going to talk through all of these parts, how we've fitted Node everywhere. Everything is Node. Spoilers. Right. So number one. Engineers create repos. So whenever a new person starts working on our microservice stack, we point them to this repository. It's a repo in GitHub that I've made. It's called Microservices. It's just full of readmes. So we've got 3 big documents that we like everyone to read. There's one about like the culture and why we do things and the reasoning behind it all. There's one which is like this is like the whirlwind tour of typing these commands and these things happen. And there's one around kind of I'm stuck. What do I do? Inside this engineering guide, the kind of like the first steps that you do are basically go and npm install this module. Once you've done that, the steps to create a new project basically say go to your console, install the module, run this tool called dockyard create, and I'm going to cover how that works briefly in a second. So I want to create a new service. It will ask me what I want to call it. I'm an R over it in orbit, and I'm going to give it a go. It's then going to ask me more questions. It's going to say, am I on the internal network? I'm going to check, because we have a lot of remote workers, and it's easy to forget that you... Yep. It's then going to say, looks like you're in a folder with some code in it, so I'm going to guess this is like your Git folder, and we're going to go off folder, and can I put all this stuff here? I'm going to say yes. It's then going to say, who's going to own this service? So we have this idea of pod ownership. So whenever a team builds a service, they are responsible for it. So if it goes down, they're the ones that have to kind of bring it back up. That works fairly well. You can try and type garbage in at this point, and it will say, no, you can't do that. We validate this against kind of the idea of Slack groups. We could find a cleaner way of doing that, but as a ease of access, it works surprisingly well. So I'm going to go ahead and type in a legit pod name, and it's going to say, what kind of project would you like? So we support Node.js, we support Python, kind of, and we support micro UIs. I'm going to pick Node.js. It's going to say, would you like Redis? Yes or no? Yes, please. It's then going to say, would you like a SQL database? I'm going to say yes. It's then going to clarify if I'm happy with this. I'm going to go absolutely. Then I'm going to go make a cup of tea. And just kind of chill out for 5 minutes. And when I get back after those 5 minutes, it's going to have done a whole lot of stuff for me. It's going to have created the GitHub repo. It's going to have given me like a base template for the project I picked. It's going to have built all of the infrastructure. It's going to have deployed to all of the various places. It's going to have provisioned SQL servers and backups and failovers and staging versions, and it's going to have created all these things, and it's going to create Redis. All the CI pipelines are going to be made. All of the secrets are going to be in all the right places, and it's just magical. Right, so just now at the start, we started off with this kind of funky npm install, and then we're kind of jumping into this command. How does that work? When you write your package JSON, you can put like a bin section in there, and you can specify commands, and you can link them to JavaScript files. As long as those files that you reference are marked as executable, as long as they start with the hashbang node, when you npm install that module, you'll simply gain those command line binaries. So one key point to make here is that we use npm as a distribution tool, and it works really well. Like, all of our internal engineering tooling is installed, as you saw, via this. All of our build tooling for all of our CI stuff is all built through this. Everything is like an npm install -g, here's our project. And like the beautiful thing about that is it works on OS 10 and Linux, and it's a really clean way of distributing our code. So we've got our project. We need to write some code. What happens next? Well, If I click through to GitHub, I'll find all of the base template that it's given me, which I've got on my file system. I've got all these dot files and everything. It's all kind of set up with NodeMon and everything. If you poke into the dependencies, into the package.json, into dependencies, there's this one funky dependency. It's a dependency on this project called the Node Toolbox. And if you dig into the README of that, we've got some kind of reasoning on why we built this module. So I'm going to go ahead and show you what's in it, and then you'll kind of appreciate why we've built it. So here's an example. I'm going to require the Node Toolbox. I'm going to use the routing app to say, I would like the Express app, please. And I'm just going to attach routes to it. Does anyone in here use Express? Keep your hand up if you think you can name all the modules that you need to run Express. There we go. Job done. When you have 150 microservices and everyone's building services, you don't want people to waste their time working out what are the 10 modules that you need. These 5 lines give you access logging, they give you metrics, they give you error catching, they give you the works. Like 5 lines, boom, job done. Next up, this one's slightly taller, but this is for caching. You take an object, which is your cache key, you take the object that you want to store, you say, store my object in the cache. If you ask for the Redis cache when you built the dockyard crate in the beginning, it would just go to Redis. If you didn't, it goes to like an in-memory cache. It's like caching, job done. Everyone gets caching. It takes like 5 lines. Again, you get metrics and logging and everything, all that good stuff that goes with it. We've built an RPC module, so you can expose functionality. So you can expose an add function, which has this input schema and output schema, and you can define what it does. You can then write code to consume it. So this is like a really clean way of enabling teams to share function calls without having to work out how to mess around with passing arguments across their Express servers and all this jazz. It also opens up nice opportunities to use different transport layers. So we're playing with like persistent TCP between services and all that kind of funky stuff. We do a lot of some publish and subscribe pub/sub, whereby you publish events onto topics and the events come back down. There's a nice wrapper around all of that, so we can kind of hide some of the complexities in those technologies. And again, you get metrics and logging and all this other cool stuff. We do databases. This was a really good one. I got late to this database party. And when I came to implement this, I found 3 teams had already implemented databases, and each of those 3 teams had spent like 2 weeks implementing databases in different ways. And like when you have hundreds of people in the web team, that simply doesn't scale. So we built the database into here. Notice like you don't have to pass the access credentials in. Like if you ask for that database at the beginning, it just kind of connects and goes to the right place. So it's like it's a beautiful thing. So the key takeaway here is that we've built one module that wraps all of these other modules, and it saves our engineers time in working out how all these NPM modules work. There's kind of too much choice in NPM. You can easily spend weeks working out which modules you want to use, how you build your which logging module you pick, connecting your logging module into your Express module and up into your pub/sub. It's chaos. So yeah, we have this one module, and it kind of wraps everything. Cool. So we're writing features, we're using the toolbox, it's really easy, we're shipping code really quickly. When we push commits to GitHub, we use staging and master branches. You push a commit to one or the other, and you'll get a staging or production build. This is what our Travis logs looked like for a while. You'll notice that we have that cool code folding thing going on that Travis. Does anyone here use Travis? A couple of people. Cool. So by default, like you build logs are just like this massive scrolling text. It's really hard to kind of read. Like we had a lot of engineers talking to us like, how do I read this log? What am I looking at? I don't understand. So we went about trying to ease how we view the logs. So you can see they're kind of like, they're collapsed on the left with a little arrow. It tells you how long each one took. If I expand one of these, you can see you get that like nice little gutter effect on the left, so you can see the indentation. If I expand out another one, you can see that I think this one has double indentation. Yeah, so on line 3894, you can see it's double code folded. So this module here, we call this the Travis helper. It kind of looks like this. And this was one of the finest modules that we built without really realizing what we were building. So this is just an async await module where you give it a bunch of bash commands, and it will run them one after the other, and it will give you whatever output you got. Any output that was produced by those commands gets nicely indented with that gutter effect, and we output the relevant lines to cofold. And this was really powerful, because when we started down this microservice journey, all of our deploy scripts were bash. And I don't know if you guys have seen big deployed scripts in bash, but it kind of gets a bit unwieldy fairly quickly. Certainly if you want to start timing how long things take and kind of wrapping all these things, it gets a little bit murky. So we managed to move, well, this was like an easy stepping stone for the infrastructure team to basically get on board with using Node.js. And like, they were keen to use Node in the beginning, but they like hopping directly into like the callback and streaming world is quite a challenge. But writing code like this, where they're just kind of like, oh wait, the Travis helper, here's my bash, get some output, jam it into the next command, off we go. Like, it was a really easy way for them to kind of take that first step into Node. We actually had an amazing thing happen the other week in the office. So one of our engineers, like a middleweight engineer, put in a pull request. And he put it in our Slack channel, and he's like, guys, got this pull request, can someone review it? And one of the infrastructure guys jumps in, he has one look at it, and he's like, this can't possibly work. Like, there's no way this is going to work. And the engineer who writes JavaScript all day, every day, was like, oh, blah, 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 and he fumbled, and he's like, oh, do you know what, this probably doesn't work. And he's like, do I make tea? Like, what's the forfeit here? So it was amazing to see those infrastructure guys growing towards Node as we kind of provided them that kind of stepping stone. So one thing to take away from this, like, that async await kind of syntax is a really good way of kind of getting people to take that first little step. They don't really need to understand too much about it, but you can run commands like sequentially. It's worked really well for us. And kind of going back to this, you might be thinking, man, this is a really dull library. It served its purpose, but we actually stopped using hosted CI after a while. When you have like 150 services, paying people to run your builds is not cost effective. Especially when you're kind of updating dependencies, you get through hundreds and hundreds of builds a day. These libraries are an amazing place to latch in and just build your own CI, because you know when commands are starting, you know what the command output looks like, and you can webhook those off to wherever you want to put them, which is exactly what we did. So I built a CI service which has its own Kubernetes cluster. It listens to the GitHub webhooks. When it sees there's a push on a branch, it will go and trigger builds on the cluster. It'll pull down the code, run our deploy scripts. Our deploy scripts webhook back to the CI service, and you get like nice tailing output, and like, Travis, job done. So that was, we can run builds really quickly just by doing them in-house. It's food for thought. Okay, so our builds are running. We've npm installed our build scripts. They're all written in Node. Things are moving nicely. We're now going to go and build some containers. Does anyone know what these modules have in common? Cool. All these modules have like a native component to them, so they all require you to have GCC and to compile a bunch of things in order to get it working. I can see a few people nodding. That is a problem, especially when a lot of us work on these things, whereby if you compile something on OS X, you can't simply copy it into a Linux container and expect it to work. This is also a problem if you use hosted CI, whereby you're probably running some kind of Ubuntu container. If you're trying to push your code into an Alpine Linux container, it's not going to play ball. So moving these modules into containers is a lot of faff. And you'll find that these modules are you're going to want some of these modules, basically. V8 Profiler gives you the CPU profiling in production, which is invaluable. And that gRPC module is like Google's, like, if you touch any of Google's modules for any of Google Cloud Services, you will get that. You can't not have it. So there's a problem. We've got a fairly good solution to it. I haven't put the actual code in here. This Docker image is actually in the public domain, so you can actually have a look at that, and you can Docker history that Docker file and see what we're doing. But the general approach is we pre-compile those 5 modules into the container, and then when you come to run the container locally, we copy everything in, and then just copy the 5 default ones over the top. And that saves you having to wait for the npm install or the npm rebuild, which takes ages, like minutes. And so you can convert like a thing that would take 1 or 2 minutes down to like 5 seconds, which is a wonderful thing when you're trying to speed up builds. These are some graphs of our memory usage in production for 2 different services. That is the complete container running a Node.js service. It took us quite a while to get the Node memory usage of Node under control. So these are the 4 flags that we ended up hunting for. They basically say don't be lazy and try and be sensible about what it's doing. Your mileage may vary with these flags, but if you're trying to, like, if you use a really small Heroku instance, for example, you're going to need something like this. Anything where you're trying to squeeze as many containers as possible into one host, it's worth looking at. So those are 2 of the problems that we found with getting Node into containers. There are a few others. It is a bit of hassle, but it's definitely worth it. Having like a container that you can just push to wherever you like is incredibly valuable. You can run our production stack on our laptops using a tool called Docker Local, and you can just spawn all of your containers locally and just see how they all interact, which is really valuable for debugging. being able to move your containers from cloud to cloud and everything it's definitely worth it. Okay, so the containers go to production. Once the containers are in production, we needed a way to kind of help our engineers understand exactly what's happening. So we ended up building a bunch of services using all the previous tooling, which basically consume the Kubernetes API. So all of our services are running in Kubernetes now in Google's cloud. They do like a hosted Kubernetes. It's surprisingly good. And they have like this cool API, and you can ping it. So we have this service which basically polls the API every 10 seconds or whatever, and it produces like this nice read-only web page where you can see every container host that we have, all the services running on them, how much resource allocation they've got. If they're, it's kind of hard to read on the projector, but you can see if they're healthy or they're unhealthy or they're crashing or whatever, how many times they crashed when they were deployed. And like you can click on a service and you can see all of the 7 container hosts that that service is running on. It's like a really nice peek into how Kubernetes works without exposing our entire engineering team to, hey guys, this is how Kubernetes works. You know, some people aren't going to enjoy that. That leads me to engineers get feedback. So we've got a service in production. What do we, like, how do I know what's going on? We have adopted a lot of chat ops in this area. So we have a lot of bots kicking around in our Slack channels. So the first one at the top is the alert bot. So whenever you make a new service with that tool that I showed you at the beginning, it's important to advertise to your team that, hey guys, Dave just built this service and you've got to own it, congratulations. So everyone gets like this little message saying someone's built this thing, here's the repo, here's the alerting dashboard, you know, have fun with that. Whenever builds trigger, we build them ourselves on our own service. We have this CI bot which informs people on Slack what's happening. So you can see when a build has been queued, when a build started, when a build's finished or failed, why it failed. You get like a nice little Slack thread telling you what the hell is going on. We did a lot of this stuff because people simply didn't fully understand what was happening with their services. Like we're reducing the barriers to entry so much that people get confused as to how simple it is. So people were pushing commits to master and be like, how do I deploy this? Whereas nowadays you look in Slack and your Slack channel will light up saying, you know, you're deploying this thing and here's the build steps as it goes. We have an alert bot, so we use Grafana to do our alerting. It's got a nice UI where you can drag sliders and things. That posts to this alerting service, which has a Slack bot where we post the graph. So you can see like things are broken. What are we going to do about this? You can have chats about it in Slack inline, debate it, fix it. You get the what's that called? There's a bunch of services which will poll your websites periodically and tell you when they go down. There's a whole bunch of them. Status Cake is one of them. There's a whole bunch. We do that in-house because we can poll it to Slack and tell people. So it's really obvious when your service is broken because your Slack channel lights up and you get the graphs and you get the messages saying it's broken. And as soon as it's back up, Slack edits the message and you get the green message again. When we throw errors in production, the Node Toolbox catches all these errors and we throw them to Slack. So you can be like, oh, it's crashing. It's crashed 4 times in production. We need to do something about this. And the nice thing about some of this, like, I can get my phone out right now and see all of this stuff. And we can put buttons on these things. So like the previous buttons down here, there's a redeploy button. When you run a build, you can click, you get a cancel button. Like you can do all this stuff on the train without getting on the corporate VPN. Just pluck out your phone. You can see the alerts. You're like, oh no, what do I do? Scroll up, hit redeploy on a previous build. So it's a really clean way of getting people to interact with your stuff without getting your laptop out, which is wonderful. It goes on. We have an access bot, which we're using to manage access, I guess, to various things. So we're locking down data and everything based on what team you're in. And you can now ask this access bot, you know, I want to join this other team temporarily. Can I get access? Then someone in that other team has to click approve. With Slack buttons, by the way, you can tell who clicked the button. So you can be like, you can't click that button. You're not allowed. Yeah, and this basically talks to Active Directory and GitHub and everything and kind of adjusts your permissions on the fly, which is kind of nice. We've got a whole bunch of others ones. Like we found that as we built all this really cool stuff for microservices, all of the engineering team got really excited by it, to the point at which they were all like trying things in the evening and the weekends. And when things don't work, they just jump on Slack and message people. So we ended up putting like a little casual message in there to say, by the way, we do try to sleep in the evenings. If you can wait, try again later. This one in the middle right is a really cool one. How many guys use Jira? Anyone use Jira? A couple of people. Some Jira-esque ticketing system, maybe. If you use Slack, like when you've used Slack, going back to a ticketing-based system where you've got to type your messages on the tickets is really painful. So we've cooked it up so that when you drag a ticket across to like the open channel, you get a message like this. If you click create channel, you'll get a Slack channel that you can type in. Any conversations that happen in that Slack channel get archived onto the Jira. Any messages on the Jira get archived back into Slack. So you don't really have to leave Slack. You can just like have a really good chat. And like it swaps all the code tags and it's like backticks and it tags them. If you at people, it fixes the names and beautiful. They got people DM me on GitHub, I get a Slack message. It's a bit nicer than the flurry of emails that you get. If anyone here works at any of the companies that could benefit from this, like this is what good chatbots look like. That's really valuable. So a kind of a key takeaway there, like ChatOps is an incredible thing. You've got to get it right. Like in the very early days, we got it slightly wrong. There was kind of too many messages in the wrong places that kind of got annoying. We've worked out our kind of Slack layout these days. So every pod has 3 channels. One is like our private channel for GIFs and talk about going to Nando's and silly shenanigans and whatever. One's not safe for work content. One of them is for like other people, other teams, like approaching your team for like, I want to do this thing. How do I do this? How do I use your API? Can we change features? All these cool contributions and stuff. And then there's like an acknowledgement channel whereby all the chatbots are basically, putting their stuff in there. So that kind of forms a nice segregation of you have to talk around the bots, which kind of gets annoying. Okay, so I've kind of gone from the left. Engineers, we create repos. So engineers create repos using internal tooling, which we distribute via NPM. We write code with the Node Toolbox, which is a nice wrap around all the crazy modules and stuff that you get in NPM. Builds run with an in-house service written in Node.js using Node.js build scripts, again installed by NPM. Those builds produce containers which has Node in it. They go off to production and we get all the feedback through all the bots and all of everything else, all Node.js again. So it's Node everywhere, everything is Node. So kind of like to summarize what I've been doing, like we've automated everything and we've JavaScripted everything. The only things that we're struggling to JavaScript are things like the deep data world, like the machine learning stuff. Like because you can't overload operators in JavaScript, like Python has that advantage of like array plus array equals array. In JavaScript, you just can't do that. So I think we'll always struggle in that area. But generally speaking, it is definitely possible to get your infrastructure guys writing JavaScript. And like once they're on that train, like they realize the power of consuming APIs and talking to GitHub and everything, and you just fly. You very quickly hit economies of scale. This is a quick summary of like what things look like before and after microservices. So you can see building a new service used to take a good 2 weeks of faff with various cloud providers and getting installs and getting your OS set up and working out how to keep your node process up and how to cycle and auto scale and build CI pipelines and how does TeamCity work? I don't know. But now it takes 5 minutes. It takes 5 minutes, and 4 of those minutes I'm getting a cup of tea. It's beautiful. Shipping a minimum viable product now takes in the order of hours because we've taken away the complexity of picking all your modules and working out how to glue them all together. Deployments now take 4 minutes on our in-house CI, whereas they used to take 12 in Travis. That is how quickly you can do it, by the way. Like, it's amazing how quickly you can run builds when you do it yourself. And that's mainly because you can bake your dependencies in. Nowadays, people don't need support to build a new service. Like, I have no idea when people build new services. They just build them and they consume them and they're all very happy and they're all shipping new services. They don't have to approach anyone in our team to be like, I want to build the service. Can you do these things for me? So they kind of very much, there's lots of freedom. So like they can build new services in genuinely half a day. And that's an incredibly powerful thing, to the point in which like innovation is now cheap for us. Like we can try something, we can get it in production in half a day, and we can see if it works. And if it doesn't work, we'll just delete it and move on. And we don't have to like pour through all your legacy stuff and your monoliths and try and hack code to make your new stuff work. And then you kind of don't want to delete it because you put so much time into it, and then it kind of lingers for a while and it goes stale and it gets all horrible. So yeah. Cool. That's most of my points. Thank you for listening.